Hello and welcome to another ANSYS video tutorial. In this tutorial we are going to look at how to solve this hand crank combined loading problem. So here we have a hand crank mounted in two bearings. So you can see at the end of this disc on the end there's 100-pound weight hanging off of that. The idea is that you come up to this part of the crank, and this is the handle, and you would spin this handle around and lift the 100-pound load. Or if you spun it the other way, you could lower the 100-pound load. Bearing A is a radial thrust bearing, so it can handle all loads in a planar direction as well as an axial direction. Bearing B is a single radial bearing, so it cannot handle the thrust. There are other loads applied to this handle, a 20-pound load in the minus X direction and a 50-pound load in the minus Y direction. These loads are just fake loads made up to make the problem more interesting. The overall goal is to determine where the maximum stress occurs and what the magnitude of that maximum stress will be. So we will first develop this model in SpaceClaim, and then we will read it into ANSYS Mechanical and solve the problem. I'll show you a couple ways to develop the model in SpaceClaim. One will be using just points created in SpaceClaim directly, and the other method will be reading in a file that contains the coordinates of those points. So after opening SpaceClaim, I always check my units. So I come up here to File and then click on SpaceClaim Options, and the options will come up. And I come over here and make sure that my units are imperial. I'm in inches, and I'm going to use decimals, degrees, and these other settings. You can see that I have this set for this document, and you can change it for all new documents or whatever you'd like. I'll leave it at this new document, and since I didn't need to change anything, I can go ahead and hit cancel, and I know I'm working in English units. So the next thing I like to do is change my sketch plane. You can see here that this sketch plane is in the XZ axis. So I will right click and left click on select new sketch plane. And now you can see that you can scroll through by moving your mouse to the various sketch planes. I like to sketch in the XY plane, so I will highlight the XY and then left click and select that. Now I can come up here and click Plan View, and I'll look at the XY plane face on. I can come here and click to insert a point, and then I can scroll with my middle mouse button and scroll in and zoom in. If I want to move the sketch plane, I can hit Control middle mouse button and drag the sketch plane to where I'd like it to be. Now I can come here and click the center and locate one point, and that'll be my origin. And now I can hit Shift and I can drag this point to wherever I want to create my next point. And you can see that I can enter in the X and Y coordinates. So I want to move this along here 10 inches, so I will click the highlighted box there in blue. I'll type in 10, enter, and that'll move that point along there 10 inches. Again, I can control middle mouse button and move my structure down, and again just hit shift, move my cursor, and since the horizontal box is lit in blue, I can just type 10, enter, and that's the location of my next bearing. Again, I can control middle mouse button, move my structure, come back to my point, hit shift, and I'm not clicking here, but hit shift and then move my button, and this one I will go 5 inches, so 5, enter. this is where my turn occurs. And you'll note here that I didn't have that on 0, so it put the point way down here because I didn't enter 0 in. So to correct that, what I want to do is come up here to the undo button, and that'll undo that. Come back to my point, get on it, hit shift, move my cursor along here, do my 5 enter, and make sure that's set on 0. Again, I can hit shift, now move my cursor up, and I go up 8 inches. The highlighted region right now is for the horizontal, so I'll just hit my tab button, and that'll change to the vertical dimension, and I'll hit 8, enter, and one more. I'll hold down my shift, move my cursor, and I'll keep it at a vertical change of 0, and this is 5 inches, so I'll hit a 5, enter. And I now have created all the points in the structure that I need to. I can go ahead and start to build the structure. I'd like to show you another way to enter these points. Often we'll have more points than just this handful, and it's a lot easier to read in a file that contains the coordinates of those points. So I'm going to come up here and left click on sketching plane and then right click and hit delete and delete all those points. I can hit the home button now, and I'm back to my XY drawing plane, and I could click on plan view and look at the sketch plane face on. So I've created this text file, and in this text file it looks like this. So there's not a command line or a descriptor, a symbol that will let you comment these files that you read in to give it geometry. So before I run this file or this code, I need to delete all of this text here. I have the text in here to help remind you of what's going on and how to enter the data. This first comment line or command line, 3D equals true, means that we're looking at 3-dimensional geometry here. So I will enter in an XYZ coordinate for each point. The other thing that you need to note is that when ANSYS or SpaceClaim actually does this, you need to enter in the Z coordinate first, then X and Y. So these coordinates here are actually Z, X, and Y. And that's what this little reminder right here says. Then I need to look here, and it says that the blank line between coordinates makes it a point instead of a line. So ANSYS often thinks that you want to connect all these points together with a line or a spline. And so by separating each data point by a space forces ANSYS to just make it a point. If I took these spaces out, then I would connect, the points would all be connected with a spline type fit. And in this case, I don't want that. I could come here and type polyline equals true, and then that would give me a straight line between each of the points, and that could possibly be helpful. But since I'm not creating beams, I'm just going to go ahead and delete this comment and leave them as points, and then I'll come back and use the circle and generate my cross section and my members a different way. So I will go ahead and cut these points off, all this information out of here. I'll hit Control X and delete it. Then I can file and hit save, and now I can come up here to, I can move this window out of the way, and I can click on my structure and come back up here to either file and open, or I can, and then click on it, or I can actually come here and go to assembly and click on File, and if I click on File there, I have my crank points, and I can click on Open, and you can see now that it has built a model that has those points in it. So that's another way that if you have a lot of points, it's very fast and easy to check your points and make sure that you have the right points in there. So I want my first beam to come along to here and then come up and out here with my handle. So I'm going to go ahead, and you can see that when I right click right here, I can select new sketch plane, and as I scroll through, I can get the new sketch planes, but it's a little hard to see when you're in plan view. So I'll hit my control middle mouse button, move it more to the center, and then I'll actually hit my middle mouse button and rotate it a little bit. And now when you move around, you can see that you can enter in these different planes. I'll get the ZY plane highlighted and click. Now I'm entered in that plane. I can hit so that I'm looking down the x-axis, and that will orient everything for me to look straight down that x-axis. Control middle mouse button, move it to the center. Middle mouse button, scroll in so I can kind of see what I'm doing. Move it. And now I come back up here to sketch, and I can click on the circle. And when I click on the circle, I can click on my center point and click. And the diameter of this circle, I'm going to make 1 inch. Nothing was stated in the problem, so I'm just going to assume a 1 inch diameter. And I'll click 1, enter, and there is my 1 inch circle. I can hold down my middle mouse button and rotate this, kind of get it on an edge. I can see my positive x-axis is coming out of that direction, and I'm ready to pull this to extend my shaft. So to pull the shaft, I need to come up here and click on the Design tab, and then I can click on Pull. And then I come down, I can see that my circle is highlighted. I can click on this yellow axis that's coming along the x-axis, the direction I want to pull this. And I can zoom this in or zoom that out if I want. To make sure I'm going in the right direction, I'm going to actually hit my control and move my structure down a little bit. And now I can see the other points that I have created. Here are the x-axis points, then my handle comes up and then down. So I'm going to go ahead and highlight this, and I can click the pull. And one thing that is also nice here is I can hit the up to command. So if I hover over this up to, it says click an object to specify a destination to which you want to move the object. So I'm going to come here and I'm going to click on this, move it down here. Then I'm going to come up to click on the up to and click this face and then click this point, and you can see that it extended my shaft up to that point of interest. Now I'll do the same thing by moving the sketch planes and creating a beam that goes vertical here, and then the rest of my handle coming out here. So if I hit escape, I'll leave the pull mode. Then I can right click, and you see that it says use last sketch plane. I'll go ahead and click on that, and you can see that it sends it down here. I can right click now and hit select new sketch plane and come to the end of this beam, which would be the beginning of this one on the top, and I can click enter. Now I can come back up here to sketch and click on circle, come to this point, and you sometimes want to zoom in pretty good to make sure you get the right point. I'll click on that and stretch a 1 inch diameter circle. Now I can zoom out a little bit and make sure I see the other grid point here so that I know that I'm going to be able to pull that. So come back to design, I'll click on the pull, and I can come here and click my arrow and start to pull it. Then I can come over here and click up to, click this face, click the point, and that will pull that handle up to the next point. Now the only thing I need to do is change my sketch plane and draw the bar that goes in between those two horizontal pieces. The best way to do that is to control middle mouse button click and move your structure more to the center. Then I can hit escape and back out of the pull command. If I right click, I can use last sketch plane. And now if I right click again, I can select new sketch plane. And I'm going to come back here to my origin and go up the y-axis so that now I'm building an origin or a sketch plane that will let me draw this vertical part of the hand crank. So I'll come up along the y, click on the y-axis. That is now my sketch plane. And I can come here and rotate this with my middle mouse button to the position that I would like it to be at, so that I can now draw this new circle. And if I zoom in here, I can get to where I can see this pretty well. Now I can come to sketch mode and circle, click on the center point there, and make this a 1-inch diameter circle. So type 1, enter. And now I can pull this. So go back up to design, come to the pull tool, and highlight this center circle. And it gets a little hard to see. So with this, it can get a little bit confusing. So what I will often do is I'll come over here to my structure tree, and I will unclick the solid that will help hide that body so that I can see what I want to pull. So if I click on those and make them so they're not shown, that's helpful because now I see the face that I need to pull and I can see it where I need to pull it to. So I can come here, click on this face, or I can just simply come here and click on up to, click this face, click this point, and now I have my cylinder going there. Now if I come back and click on the unhide, both of those, you can see that we're starting to get a pretty good look at our geometry. If I click the X, we'll look down the X axis at this. I can click the Z, and this will put the Z coming straight out at me. I can middle mouse button this in, and I'm starting to get a pretty good look at my crank. The only thing I really need to focus on now is finishing up these edges so that I have a good connection, or what I would expect in the geometry of the hand crank between these beams that are being connected here. So one of the best ways to fix these corners is to use the pull revolve command. And so if I click on my body here and get out of the pull tool, and I can hit escape, and then I can come over here and I could hit spin or pan or any of these things, look at different settings for default orientations for my structure. Oftentimes it's just as easy to click on it with your middle mouse button and rotate it to the directions that you want to work on it in. So that direction looks pretty good. I'm going to go ahead and zoom that up, control middle mouse button, and bring it back down so that I can see it. Now basically what I want to do is take this edge right here, or this part of the beam, and rotate it around to this edge. So if I come up here to the design, click on pull, you can see this revolve button or option, and what you can do is click on this, then you come over and you click the face that you want to revolve. There are various options to fill in these rounded corners and edges. I think probably the easiest way is the way you know, of course. For me, that will be to come and click on all the solids. So I'll left click and then shift left click and select all the solids. Then I'm going to come up in here to and and combine those. So what I'll do is I want to merge those bodies and combine them into one. So I'll come up here to the combine tool and hit combine. And when I do that, you can now see that I have one solid and all of these have been combined. Now I'll middle mouse button, roll this around and zoom in. And what I'll be able to do is blow this up a little bit so that we can see everything. And I'm going to come up here and click off the structure. I'm going to back out of the combine tool by hitting escape. Now I'm going to come to the pool tool and I'm going to select this face right here. I'm going to come up and click on the revolve button. Then I'm going to come down and I'm going to alt click this horizontal line. And that will let me revolve this face around this horizontal line. So doing that, I can revolve that face around there. I can bring it to its edge, and that has filled in that corner. Now I'll do the same thing down on the bottom edge. Now that I've got my corners rounded here and here, I could, if I needed to or thought I should for this particular problem, I'm not too concerned about these corners in this case, but I could come to the design tool, click on pool, grab this edge, and I could pull this edge and make it a fillet or rounded or something like that. But I'm going to go ahead and leave them as they are, and I won't put anything there. So zooming back out of this and centering everything, if I come over to my structure tree, when I look at this and hit escape out of all this, I can kind of see that I'm missing some points. And so if I come here and click on my curves and open this up, I can see that my points have been taken away. They were taken away when I pulled these cylinders and this rod through through the points and up to the other points. That's where they kind of disappeared. So what's handy with having the file with those points in it is all I need to do is come back up here to assembly, and I can click on file and then click the same file that I had used and click open, and I now have my points back in there. You can see them over here that they're listed, so I don't have a duplicate. I could come up to point 6, left click on it, then right click and delete it. And now I have my points 1 through 6, and I can close that back up. I'm not going to need to transfer my sketch planes over into ANSYS Mechanical, so I can left click on the top one, then shift click the bottom, then right click and click on delete and delete all those. Now I've got a pretty clean model. I've got my shaft, got good corners on it, and I've got my key points. And I'm about ready to bring it into ANSYS Mechanical. There are various options to fill in these rounded corners and edges. I think probably the easiest way is the way you know, of course. For me, that will be to come and click on all the solids. So I'll left click and then shift left click and select all the solids. Then I'm going to come up in here to and combine those. So what I'll do is I want to merge those bodies and combine them into one. So I'll come up here to the combine tool and hit combine. And when I do that, you can now see that I have one solid and all of these have been combined. Now I'll middle mouse button, roll this around and zoom in. And what I'll be able to do is blow this up a little bit so that we can see everything. And I'm going to come up here and click off the structure. I'm going to back out of the combine tool by hitting escape. Now I'm going to come to the pool tool and I'm going to select this face right here. I'm going to come up and click on the revolve button. Then I'm going to come down and I'm going to alt click this horizontal line. And that will let me revolve this face around this horizontal line. So doing that, I can revolve that face around there. I can bring it to its edge, and that has filled in that corner. Now I'll do the same thing down on the bottom edge. Now that I've got my corners rounded here and here, I could, if I needed to or thought I should for this particular problem, I'm not too concerned about these corners in this case, but I could come to the design tool, click on pull, grab this edge, and I could pull this edge and make it a fillet or rounded or something like that. But I'm going to go ahead and leave them as they are, and I won't put anything there. So zooming back out of this and centering everything, if I come over to my structure tree, when I look at this and hit escape out of all this, I can kind of see that I'm missing some points. And so if I come here and click on my curves and open this up, I can see that my points have been taken away. They were taken away when I pulled these cylinders and this rod through through the points and up to the other points. That's where they kind of disappeared. So what's handy with having the file with those points in it is all I need to do is come back up here to assembly, and I can click on file and then click the same file that I had used and click open, and I now have my points back in there. You can see them over here that they're listed, so I don't have a duplicate. I could come up to point 6, left click on it, then right click and delete it, and now I have my points 1 through 6, and I can close that back up. I'm not going to need to transfer my sketch planes over into ANSYS Mechanical, so I can left click on the top one, then shift click the bottom, then right click and click on delete and delete all those. Now I've got a pretty clean model. I've got my shaft, got good corners on it, and I've got my key points. And I'm about ready to bring it into ANSYS Mechanical. So after opening up Mechanical, this is what we see. We come to Geometry and open the drop down. We can see that we have one solid, and it seems to be in good position and the right size, and it came in all right. But one thing that you will notice is we need to put boundary conditions on these on this system, and we're going to have to put those bearings in here. And in order to put those bearings in those boundary conditions, we need to have a point that we can select to do that. So if I come down here to static structural and try to enter in those conditions, for example, when I hit displacement and I come here to click on a vertex and I scroll up and down this model, I don't get any vertices to light up. If I come here to the edges, now you can see the box and a vertex indicated at that point. If I come up here, I can see a circle with a vertex in the center of it, but where I created these vertices in ANSYS along this shaft, or excuse me, in SpaceClaim along this shaft, they do not appear. In order for a key point or a point in SpaceClaim to come through into Mechanical, it has to be on a face or an edge of the system. And if we go back and look at our SpaceClaim model, these interior points here are not on a face or an edge. So we need to correct for that. Probably the easiest way to do that is to come and split the body and create these individually. This could have been done when we were developing the model and creating this, but I have done this to show you and kind of emphasize the importance. So if we click on the Z and get it straight in the Z direction, I can middle mouse and rotate it. And what I'm going to do is I'm going to come back here to the Design tab, and I'm going to click right here. This is Create a Plane. So I can click on this and create a plane. and it's going to be based on the selected objects. And so what I want to do is come down here and click on this main beam down here on that solid, and then I'm going to come up and click on the plane. And you can see that that plane showed up in that direction, and I actually want to get it perpendicular to that direction. And so what I will do is I'll hit undo, and I'll click on just this face. And when I click on that face and then come up and hit the plane, you can see that I have a plane in that direction. Now what I'm going to do is come and click on the move tool, and I'm going to move this plane down along the axis of the shaft till I'm in between those 2 points, and I'll let it go and click off the structure. Now I'll come up here to the design and click on split body, and I'll click this body, and then I'll come over here and I'll click on the plane that I just created, and you can see the split that develops. Now I'll go ahead and hit the escape button because I've split that body. I don't necessarily want to delete one half or the other. Now I'll come up to the design and the pull tab. I'll highlight this member here, and what might help is now you can see that I have 2 solids. I can come over and unclick that solid so it's not seen. I can spin this around, click on this face, and I will use the pull tool up to a point. So I'll click on this face and then that key point. And now I've got that part of my system built. Now I can come and show this body again. And so I'll click on it, and you can see that this is the structure that I have. And so what I can do now is I can click on pull and up to a point. I can click on this face, but the thing I want to make sure I do is click on the no merge option in the pull menu. So I'm going to click on no merge. I'll click on the up to, and I'll come and click this face, rotate it, and click my key point. And now you can see that I still have 2 bodies. I've got a face there, I've got a key point and a split in that body, so I'm going to be okay as far as that goes. I'll hit the Z axis to go around and get it straightened out, rotate it a little bit so I can now move my plane again. So I'll click on my plane, highlight it, I'll click move, and now I'll move it up into this region of the material, and I can click off the subject or off the body and have my plane there. I can come to design, split body, click the body I want to split, then click the plane I want to split. You can see the split show up. I now have 3 bodies over here. I can hit the escape tool, back out of that. Now I can come back up to the hide, and I'll hide this part of the body so you can see that I'm going to hide the first solid. When I hover over this, the first solid over here is lit up. So I'll check that off and hide that. Now I'll come over and click on the pull tool and the up to. I'll click on this face and then that point. And you can see now that I have 2 bodies here. It collapsed from 3. And what happened is these 2 bodies right here merged. And so if I don't click that no merge tab, that's going to merge these back into one body. So I want to click undo on that. And I'll click undo until it comes back and I have my 3 bodies. Now I can click on the no merge, click on the up to, click this face, and I'll hit escape because it's kind of backed out of that. And now I can click the face again. I'll have to click the up to, come over, click the face, and then click the point. And now you can see that I still have my 3 bodies and I still have my split there. Now I can go ahead and see the first solid and put it in there, and I can come over and keep the no merge clicked. Click on the up to, and I'll pick this face, rotate it around, and then click on that vertex, and I now have three solids, and I can highlight what they are, and I can reorient this in the Z direction. I no longer need this plane, so I can right click on it and click delete. I really don't need any of these curves going forward either, so I could delete those and get rid of those, but they did help me do the process and locate these points. So now I can hit the escape button back out of everything, come back to mechanical, come up to geometry and right click on geometry, and then scroll down to update geometry from source and click on that. And now you'll see that it's updating the geometry, and now when it comes in, I've actually got what looks like a body here, here, and then all this out here. If I click on my geometry, I can see that I have three solids, and that's what I wanted to see. You can see I have question marks on two of them. All I need to do is right click and come down here and assign the material. And so I'll assign the material as structural steel. Then I can just left click here, and this one will highlight the details of that system. And I can click on material assignment and click structural steel. So now I have my geometry all brought in. I have these distinct places where I can put my boundary conditions or my bearings. I can go ahead and close this, and now I'm ready to go through a mesh and then apply my boundary conditions and loads, and then look for the parameters I want in my solution. As we work down through our project tree, we can look at the materials and see that everything is structural steel. We can double click on that if we want to see the details of the properties. Then we can close that window. When we come to connections, we should see some contacts where our shaft is bonded together. So showing up here first is this contact, and you can see in the top view it's this member connected to this member here, and so you can see the contact. You can see that it's bonded, and the scoping method is automatic, and this was developed or created automatically by ANSYS, which is nice. We can look at our contact region number 2, and we can see where it's the cylinders are connected out here. So these are just the bonded joints where we will put our boundary conditions. So everything looks good there. This is bonded, automatic, and no other settings, but you still need to check those. On our mesh, what we're going to want to do is set a higher resolution. So I've come down here and I've set a resolution of a 6. You can increase that even more, but we shouldn't need that in this problem. I think we'll just leave it at 6, so 6, enter. In terms of mesh, I'm going to insert a couple methods. I'm going to insert the first method. I'm going to pick this body, so I'll go to the body select and I'll click this one, control click this one, and then click on apply, and I have my two bodies. And I'm going to switch the method from automatic to multi-zone. Even though in my geometry I've only got one zone there, this multi-zone helps us get a pretty nice mesh. That's the only thing I need to change here. I don't need to change anything else. I'll come back up to mesh, right click, insert, and I'm going to insert another method. So I could come over here and insert method, or I can just come up here and click method, and here's my second method. I'm going to leave this one as automatic, but I'm going to come and click this body and then click apply, and I'll leave that set at automatic. So I'll now go ahead and generate the mesh, so I can come up here and click on generate. The meshing's done. I can come and click on mesh, and I can see the mesh. I can see my endpoints here look pretty good. This end doesn't look too bad. That looks like a good mesh. Certainly fine enough for a first draft of what I'm looking for. So I'm going to go ahead and leave it at that. I'm going to come to static structural, and I'm going to enter in my boundary conditions and my loads. First off, I'll have a displacement boundary condition, and I'm going to put that boundary condition on a key point right here. So when I click this key point to select it, it'll click there. I'm going to come over here and click apply, and you can see that I have one vertex, and that's where I will put that boundary condition. The boundary condition is going to be 0 in the x direction. If you remember, this is our thrust bearing, so that one will be 0. And then I also have x or y and z restraint due to the bearing. So that's my first one. I'm going to come and enter in another displacement boundary condition. And this one I'm actually going to put on the face. So I'll click the face tool, and I'm going to come here and click that face. And you got to be really careful with that, because see how that highlighted the outside face? I want it to be on the inside face. So I'm going to have to come up here to my geometry, open up my geometry, right click on this one and click hide body. And now it will hide that body, and I can rotate my structure, and I can click on the face that I want the boundary condition to be on. So I'm on my displacement 2, and I click on that face. I can come here and click apply, and I have the one face, which is the one I wanted. This is free to move in the X, but 0 in the Y and 0 in the Z. So I enter those boundary conditions. I can come back up here and right click and say show all bodies, and now I have my structure back. I can click on this ball and look at it in the ISO view. So I've now got my displacement set. I'm ready to go and put on my loads. So I'll come up here to static structural, click on that, and I'm going to put a force. And in terms of the force, I'm going to put these forces on these faces out here. So I'll click the face select, and out here on this one, I'm going to click apply and accept that as the geometry. I'm going to come here to define by vector and change that to components. In the X direction, I had a minus 20 pounds. In the Y direction, I had a minus 50 pounds. And now I've gone through and figured out what the force needs to be to carry the torque of 400 inch-pounds. And because it's an 8-inch radius instead of a 4-inch, I don't need 100 pounds, or the load in the Z direction would be a minus 50 pounds. And that will carry the load due to the torque. So that's the force that I have out here on the handle end. Now I can rotate this around and put the loads on my other end of the shaft. So I'll come up here and click force. It enters in a new force. I'll click this face and click apply. I'll click define by components again. And on these components, I don't have any force in the X. The only force I have on this face is in the Y direction, and I have a minus 100 pounds there. Now I need to add a moment or a torque. So I'll click on a moment. I'll come over here and select this face, click apply, so I have the one face. Again, I'll pick by components, and this will be a moment about the x-axis. So when I look at my x-axis, I'll put in here 400, enter, and I can see that this rotation is indeed opposite of what I put for my Z force up on the handle. So those two should counteract. Now I can click my isometric view again. I can scroll through my forces and make sure that they look like they're doing the right things. I can look at my displacement and see that it's on that one face. And what I've done for illustration purposes is if I have set this on a vertex instead of a face. Now we're ready to go ahead and pick what we want as outputs. I certainly like to get a total deformation, and I think a directional deformation in the y-axis would be important here to see how things are bending down in y due to my vertical load on the end in the y-axis. I don't know that I'll look at strain, but in stress I certainly want to look at the equivalent stress or the von Mises stress. I could also look at the maximum principal stress. I might look at a shear stress, and I can scroll through here and see if there are any other stresses that I'm interested in. That's probably okay for now. I could get more complex with this and put up safety factors and use a probe and various things, but that would be part of another tutorial. So coming back to my model, I can close up my geometry. I've got green checks everywhere. My mesh has been updated, so I can go ahead and generate or update the mesh again, and I'll get a green check mark then on everything through my mesh, so I can click on my mesh, and once it's done, see a good mesh again. It says some of the entities were not updated because they were already meshed. Green checks through everything here, lightning bolts through here, so I'm ready to hit the solution and do a solve. This is a pretty quick solution, but I'll pause the video while it solves. Now, what you can see is that we've got red check marks, so we made a mistake somewhere. If I come down here to my messages sections, I can click on my messages, and I can see I had a couple warnings, but my error was this one, and it says a load transfer error has occurred. A load could not be applied to a small or defeatured entity. You may select the offending object and or geometry by right mouse button on this warning message. So if I right click on this error message, I can hit go to, and it's hard to see, but it goes to this point, or goes to this boundary condition here, and that's tough to see. Sometimes the right mouse button go to helps, sometimes it doesn't. But what I did here is back on this displacement boundary condition, I put it on this vertex to show you this error that you can get. And so it's generally best in mechanical if you put the forces and displacements on faces instead of on a vertex. And so if I come here to this displacement and I come up to my geometry and hide a body, so I'll right click here and hide this body. Now I can select this vertex, or excuse me, this face, and I can come over here to my displacement and replace that vertex with that face and click apply. And now I've applied that displacement to a face. I can come up and right click and say show all bodies. I can hit the ISO view, and now I'm ready to come back and solve again. You can see that I have a lightning bolt by my static structural, but everything's been applied green. I can come up here and hit solve. You noticed how that error popped up really quickly last time, but now it seems to be solving. I'm making progress, 78% solved, so this will be a quick solution. I'm getting green checks here. Everything turned out to be green check marks. If I want to slide this down, I can move my cursor till I get those double lines. Slide that down a little bit, slide it down a little bit more, and now I can see all of my outputs. If I hit my total deformation and look at this along the x-axis, or have the z-axis coming out, that looks like what I should see. I had a force pushing down on this, so I can see a large deformation there. I can see a large deformation out on this end. This seems a little bit large to me, but again, this is the total deformation. It's not just the Y. I would think that this end here would move less in the Y than this end. So if we check the directional deformation, I can see that this is 0.02 in blue, and up here I'm still light greenish, so that makes a lot of sense to me. I'm starting to trust my solution a little bit better. If I look at equivalent stress, I can see that my equivalent stress is largest right here at that first bearing, and that's what we obtained from our hand calculation model. We can also see a relatively large stress here, But up here at my handle, things are not that bad, except when I come over and look at that there's a minimum and they're at 8.3. You'll note again that on the equivalent stress, there are no negative values. It does not show tension and compression. So I can look at my maximum principal stress, and it correlates pretty well with what we see in our equivalent stress. I can look at a shear stress and see the shear stresses that I have. Again, if I look along the x-axis, I can see that these are largest here at the neutral axis of my shaft. Got a little hot spot right there due to shear in that tight edge. Essentially no shear through here where I'm crossing through this 0 from negative to positive. So that looks good as well. So this kind of wraps up the hand crank problem. Hope you found it beneficial and you can now apply it to other problems.